Welcome to Rogan's Network. So today's topic is about VLAN, the IEEE 802.1Q Virtual Local Area Network. So in this topic, we will be covering why do we need VLAN, what is VLAN, when and where to use the VLAN, how does a VLAN frame looks like, what are the ranges available, the VLAN types, the port types, and finally, the rules that must be followed in order to configure a VLAN successfully. So let's break it down one by one. So first we'll see why do we need VLAN. So what is the problem? What is the issue in the LAN that leads to the introduction of a VLAN? So the answer is single broadcast domain. So what do I mean by that? So in order to demonstrate the single broadcast domain, I'm going to take this Cisco switch connecting with 4 different PCs with the network 192.168.1.0/24 network, assigning 1.1 to 1.4 respectively. And I'm going to ping from PCA to PCD and see how it behaves. So I'm going to put this in the simulation mode first and take a packet, ping from PCA to PCD and simulate it. So at first, if you see it, the packet will go to the switch, and the switch will actually broadcast the traffic to all the end hosts connected to the switch. So meaning that the switch proves that it's simply a broadcast domain. To those who are not familiar with the topic, so all the devices that resides in the layer 2 segment are considered to be in the same broadcast domain. So on the other hand, the broadcast traffic is network traffic intended for every host on the local area network, and it is forwarded out of each and every switch ports / interfaces. So these excessive broadcast traffic is undesirable and eventually brings down the performance of a switch. So in order to solve this issue, the concept of VLAN was introduced. So wait, so is this only VLAN is the only concept that it's going to solve this problem? So why can't we just use routers? So if you have seen my previous videos, I have explained clearly that if you use a router, the broadcast traffic is not going to cross the layer 3 boundaries. That is from one subnet to another subnet. So in the subnetting, why can't we use subnetting too? Well, we're speaking about the layer 3, but the solution which is required is at layer 2. So yes, the only solution we have is VLAN, which leads to the next question: what is a VLAN? So VLAN is nothing but a virtual local area network which is going to divide a single broadcast domain into multiple broadcast domain at layer 2. I repeat that again. Let me just write it down so that you'll have an idea. Divide single broadcast domain into multiple broadcast domain at layer 2. So that's the important concept here. So at layer 2, so this VLAN were introduced to avoid the unnecessary broadcast traffic. So I think I don't have to explain more than a simple definition that I stated here, but if you want to know more, that's fine. Let's see it again. So as we have seen, the ping packet was sent to all the devices in the network. If it is a single switch, then it's fine. But imagine having 50 to hundreds of switches which is connected to this switch. The broadcast traffic is sent to all the switches and it will be totally inefficient. So the introduction of VLAN benefited in a different way, that it divides the broadcast domain, and the broadcast traffic is also restricted basically, unless and until you configure the inter-VLAN routing, which we will be seeing in the later videos. So the next question is about when and where to use the VLAN. So where can you use it, right? So if you have requirement to divide the network based on the groups, say for example you want separate departments like HR department, IT department, or engineering department, so that's when you will be using the VLAN, so that one department doesn't want to communicate with another department. So that's when you use it. So now that we have understood why, what, and when and where to use the VLANs, let's understand the frames of 802.1Q. So I have an example right here. I'm going to show it to you. As you can see, we have Ethernet frame and the VLAN frame right here, and we will be concentrating on the specific 802.1Q tag, so which is 4 byte in length, and we will be specifically seeing TPID, PCP, DEI, and VLAN ID in this topic. So meaning that the TPID. So since we're looking into VLAN ID, we have to know how the frame looks like so that we can understand how VLAN works. So the TPID, the code 0x8100, which is X hex number, that's the one which identifies the 802.1Q VLAN packet. Next, we will concentrate on the PCP, priority code point, prioritizing the traffic. So the COS and the QoS are the two different examples that I can give in this part. So COS, class of service, operates only at the layer 2, 802.1Q especially, and the QoS, the quality of service mechanism, operates at layer 3. So this 802.1P specific tagging mechanism, which is used to differentiate the traffic and also shape the network traffic accordingly. And the next topic we'll be seeing is about DEI. The DEI is nothing but drop eligibility indicator. So it will define or indicates whether the packet has to be dropped or not. So next we will be looking into VLAN ID, which is 12-bit in length. So mathematically, if you see it, so 2 power 12 is going to be 4096 unique VLAN which can be configured. So I have captured few packets from Cisco Packet Tracer and also from EVNG in order to show you an example. So first we'll look into the Packet Tracer packet that I captured. How does a VLAN, Ethernet frame looks like, and then the VLAN frame looks like. So if you see, this is the Ethernet frame. We'll be concentrating on here. So which has preamble, SFT, destination address, source address, type, data, and FCS. In the 802.1Q frame, you will be seeing the TPID, TCI, type, and FCS. So as we have seen, the TPID, which will denote that this packet is the 802.1Q VLAN tag, and the TCI, tag control indicator, which denotes which VLAN it is. If you can see, the A is basically VLAN 10. So I just configured before, and I just captured this packet in order to show you. And also I just captured some packets in the EVNG in case if you're curious to know how it looks like in the EVNG. So this is the normal Ethernet frame that I captured on the left side. If you can see it, it doesn't have any 802.1Q frame since it's just Ethernet frame. And on the right hand side, we can see the 802.1Q virtual LAN frame. So this is how it looks like in the Cisco Packet Tracer and also in the EVNG. So the VLAN ranges. So speaking about the VLAN ranges, so mathematically, if you see 2 power 12, which will be 4096, the usable VLAN ranges from 0 to 4095, out of which the VLAN 0 is reserved for 802.1P, which is nothing but for traffic prioritization, which we looked an example related to PCP, which is going to differentiate the traffic between QoS and class of service. So the VLAN 1 is default VLAN. The VLAN 2 to 1001 will be normal VLANs. From VLAN 1002 to 1005 is reserved VLAN. And finally, VLAN 1006 to 4094 will be extended VLAN. So that's all the ranges that we can use it in the Cisco. And we will jump into the next question, which is Vlan types. Two different types, which is static and dynamic. Static VLANs. Static VLANs are the one which is frequently used because it's port based. Another one is dynamic VLAN, which is based on the MAC, so which will not be discussed in here. So next question is about port types. Port types, we have two different types. which is access port and trunk port. So speaking about the access ports are sometimes called as untagged port. So if you're dealing with a single switch, then access port comes into play because it will carry only single VLAN. If we're speaking about the trunk port is also called as tagged ports. So if you're dealing with multiples of switches, then the trunk port comes into play. So which will be able to carry multiple VLAN. Alright, so just to summarize, access port, if you're dealing with one single switch, then access port is going to carry only single VLAN. If you're dealing with the two switches, then trunk port comes into play, carries multiples of VLANs. And finally, speaking about the VLAN rules. So basically, the VLANs must be in the same subnet. So make sure it's in the same subnet. Second rule is VLANs must be not be shut down. And finally, make sure you assign the ports to the intended VLANs. So make sure to follow these rules in order to configure the VLAN successfully. So that's it for this video. Hope you enjoyed it. Hope it is informative. I'll see you guys in the next video. Thank you so much.